Back into our notes. We're on section 5.5. We are going to show corresponding parts of congruent triangles congruent to each other. So this is something that did come up in that little booklet. If you remember doing the proofs in that little book. This was the CPCTC. We just hadn't quite gotten there yet, so we'll see it today. If you're good with the triangle proofs, this should not be super challenging. It's just like adding one more step onto the very end. So if you know that two triangles are congruent, then you can conclude that all of its corresponding parts are congruent. That's how we started off this chapter. We listed out all the corresponding angles that were congruent and all of the corresponding sides that were congruent. So if you show the triangles congruent, then you can assume that. We will be doing this in proofs, and the reason you will write is corresponding parts of congruent triangles are congruent, or just CPCTC. CPCTC can only be used after side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. So you have to show the triangles are congruent first before you can use CPCTC. Oops, sorry, too fast. Another idea we need to talk about is overlapping triangles. If a diagram shows overlapping triangles, it will be helpful to redraw the triangles so they do not overlap. So this should be closed right there. All right, let's go ahead and name this example. I'm just going to label the points we'll have to use: A, B, C, D, and E. So here we've got triangles that overlap each other, so our goal is to try to draw them separated or pulled apart from each other. So one thing I like to do when I'm trying to do this is to just trace over them. So one of the triangles I can see is kind of on the top left part of it. What three letters do I need to have to name that triangle? A, B, and D. Good. So when I redraw that triangle separated out, and it doesn't have to be perfect, but it should look similar, I only need to relabel A, B, and D. E exists probably right about there, but I don't really need to label it because it was not one of the vertices or corners of my triangle. Questions about drawing one of the triangles out? Can anybody see what the other triangle would need to be called? EAC. Good. EAC is going to be the other one. I'll highlight it in a different color. And again, it wouldn't have to be perfect, but it should look similar. We would have triangle EAC. Again, point B would exist over here somewhere, but we don't really need to label that. It's not one of the corners or vertices of that triangle. So Sometimes in proofs it'll be helpful if you're able to separate the triangles and draw them out individually. Questions, concerns, need more time on their overlapping triangles? Okay, keep it going. State whether the triangles are congruent and why. Then state how you know the other piece is congruent. Okay, I'll give you a minute because these ones are not printed for you in your notes, so you'll want to copy down the diagram and then think about if the triangles are congruent, why? So that goes back to that list of SSS, SAS, ASA, all of those. And then we'll talk about how we know the other piece of information that they listed above is also going to be congruent. All right, on number 1, we don't really need to separate those triangles. They're already separated for us. How would I be able to prove those two triangles congruent? So we have vertical angles there. I don't know that we need them though. So right now, I don't want to talk about these angles that they're mentioning yet. I want to just talk about these two triangles. From our list of 5 ways of showing triangles congruent, which way works for these triangles? Just the way they are. Side, side, side works for these triangles. So the triangles are congruent by side, side, side. So we could make a statement if it helps you to do that. Triangle KML is congruent to triangle, let's see, NMQ by side, side, side. Are we all on board with that? Okay, they marked 3 pairs of congruent sides, so those triangles are congruent by side, side, side. That's old. We've done that before. The new part would be then how we would know that angle KLM, so KLM is up here, is congruent to NQM. That's the angle down at the bottom left. Now these are not vertical angles. We don't have parallel lines, so we can't call it alternate interior. This is that new thing that came at the beginning of the notes. If you know the triangles are congruent, we've mentioned they were by side, 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 then we can use that CPCTC, or corresponding parts of congruent triangles are congruent, to prove this last little bit of information. So that's all we would have to put for this one. The reason would be CPCTC because we already showed the triangles were congruent to each other. So if you've understood proof writing up until this point, this is just adding one more step onto the very end. CPCTC has to come last. We cannot put CPCTC in before we show the triangles are congruent. It's got to be the last thing. Questions about that first one? Okay. Number 2. So one thing we don't necessarily need to have. Oh, no, we do. Okay. So we could redraw these triangles separately. If you wanted to, you could redraw this large triangle on this side, and you could redraw this large triangle down here. So when we do that, we have to state whether the triangles are congruent and why. So if we were to redraw these separately, I'll just try to do my best with that up at the top here. Not perfect, but it'll work. So the one that I outlined in yellow, what would that one be called? ABD. And the one that I outlined in red is ABC. Okay, they gave us right angles at angles D and C, so I'll mark that in. They also marked side AD congruent to side BC, so I'll mark that. Now, based on this alone, do we have enough information to say that these triangles are congruent? Just based on what I've marked so far. No, there's not enough information there. We've got one set of angles, right angles, and we've got one pair of sides. It's not enough. But there was one side that I drew exactly the same 2 times. Which side was that? AB. So they have that side in common with each other by what property? Reflexive. They're congruent to itself by reflexive property. And now, I think I heard somebody say it, which way could I prove these triangles congruent? HL, now that I've shown that. Okay, so this is kind of like thinking through a proof without writing the whole thing. So now I could say triangle ADB is congruent to triangle, let's see, BCA by HL. Remember, we have to be careful how we state our triangle congruence. We got to go in the right order. And now that I've said that those triangles are congruent by HL, I could go back to talking about, angle BAD is this one up here. ABC is that one up there. And yes, they would be congruent by CPCTC. Questions, concerns? Yes, ma'am?
So when you prove the CPCTC, it's only for the angle?
Angles or sides. So both of these ones happen to be angles. They could have done the same thing with the sides. Like they could have said side DB congruent to side AC. And it would have been the same reason. Good question. Other questions? When the bell rings. Questions about geometry, since that's what I'm most concerned about at the moment. Okay? All right, go ahead and draw these. It might be helpful to draw number 3 separated. See if you can think about why or how you could show the triangles are congruent. Of course, it's a bit of a spoiler alert. You should know how we're trying to show these last statements to be true with the CPCTC. But before we do that, we have to make sure we can show the triangles are congruent to each other. They gave us some information about these triangles that we could label. Okay, they said that angles K and L were congruent. They both had 2 arc marks. So I can remark those. The other ones are a little bit trickier. But if we were to trace over the triangles, like this triangle here, JMK, Sam? Switch those. There we go. All right. If we trace over the triangles, it's easier to see which angles we're talking about. So for this top triangle, I should be giving one arc mark to this angle at M. So one arc mark at M. For the other triangle, I should be putting one arc mark in where? At J. So these overlapping triangles get a little confusing because we're reusing letters, but the angles are not the same. So angle M is not the same as angle M in this case. Does that make sense? Okay, so just keep track of where things should be marked. Based on what we have marked right now, there is not enough information to say these triangles are congruent. However, what do they have in common? Good. JM is congruent to itself by the reflexive property. And now we could say these triangles are congruent by, good, angle, angle side, or AAS. Because we did that, we can say that KM is congruent to LJ by CPCTC. Questions about number 3? In my opinion, 4 is a little bit easier because we don't have to redraw the overlapped triangle separately. There is one piece of information we still need though. Sam, what is it? Good. We got to give that those angles in there were vertical angles, meaning that they are congruent. Once we've done that, then we can say those triangles are congruent by angle side angle. And once we've done that, then we can say QR and TR are congruent by CPCTC. You kind of getting the hang of how these flow? Okay, same as before, tack on CPCTC at the very end. Anybody need more time on this slide? Are these proofs not in your notes? Okay, we'll do more with the proofs tomorrow. This is enough for today's notes for you to get into your homework. So it looks like most of you had your homework packets. That's where you should be working. We'll do more with our proofwriting tomorrow.